Hey, 2.7, solving proportions. Guys, this is just wit tonight. Richardson is out, and we also have no video. So hopefully you can stay awake with just these awesome slides. All right, let's get going. We are solving proportions tonight. Okay, solving proportions, guys, it's basically just doing cross multiplication and then doing a one-step problem to get your variable alone. I really think you guys are going to get this pretty quickly. Yeah, let's do it. So here we have 5 over 6 equals x over 11. All we're doing, whenever we see that one variable, we're just trying to get the variable alone. So how do you do that? Cross multiply. So you take x times 6, which we know is 6x. That equals, and we do the same thing the other side, 5 times 11, which is 55. Again, I need to get that x alone. Since we're having 6 times x, divide both sides by that 6. 6 divided by 6 is 1. So I'm simply left with x. 55 divided by 6. So this is 9.16 repeating. So I would say it's 9.2. Sorry, I'm having some trouble with this pen tonight. There you go. X equals 9.2. Let's try another one. We're going to start off with the same thing. Here, I need to cross multiply. I know I need to take 7 times 12 and m times 8. It does not matter where you start, guys. I would start with m and 8, so that way I would have my m on the left-hand side. You are more than welcome to do 7 times 12 first and have that on the left side. Doesn't matter. So 7 times 12, 84. So that's our first step. Now here, how is this related to a problem we've solved before? It says solving proportion is similar to one-step equations using multiplication. Right here, 8 times m equals 84. Again, we need to get rid of the multiplication, like we've been talking about over and over. Undo the multiplication. To undo multiplication, you use division. Well, right here, 84 divided by 8, 10.5. So m is 10.5. This is showing your work. Hopefully we're liking this. All right. Here it is again, guys. Just talk about the cross products. Cross products is the same thing that I've been talking about. You just multiply across and there it is. All of this is in your book. Detailed description of what is happening. So check that out if you're having any confusion at all. So here's 5 over 6 equals 11 over x. Like I said before, you can start anywhere you want. You just multiply one numerator to its opposite denominator. So again, other numerator to its opposite denominator. So we'll go ahead and start with 11 times 6, which is 66. That equals 5 times 11, which is 5x. Ooh, I don't know if you can see that green. So I have to undo the 5 from the x. It says 5 times x currently. To undo multiplication, you use division. Bring down that remainder of the x. So x equals, what is 66 divided by 5? 13.2. So this could be okay, but remember, here in algebra, we need to flip that around and have x equals 13.2. All right, let's try one on your own, please. Go ahead and try this out. Pause me, come back, and we'll check out your answer. All right, so here's my answer. I have x equals 6. Again, I just did the cross products here. I started with 4 this time just to show you it doesn't matter which side you work on. So I have 4 times x, 4x equals 8 times 3, 24. Undo that multiplication. You have divided by 4 on both sides. X is 6. Now something pretty cool that I didn't show you yet is that you can check this. So I just took the original problem, removed the x, and put in a 6. Well, 4 times 6, 24. 8 times 3, 24. Big old smiley face there that it works out for us. These are the coolest ones, guys. This is something that very common mistakes happen, so just make sure you listen up to what I'm about to say and how I'm going to explain it. One, over here on the right-hand side, it says, how is this proportion different from others you've seen? Well, this proportion looks more complex, but the cross product's property is true for any proportion. Treat each numerator as a single variable when you cross multiply. So what that means, guys, is this is hooked together here, and this is hooked together here. So you're still doing the same thing you did. You were taking the cross product, a numerator times the denominator, and then a numerator times a denominator. The one thing you have to look out for is you are taking this 5 times the entire numerator. So that means you have 5 times the quantity of x minus 2. So it's not just 5x minus 2, it's 5 times the quantity of x minus 2. Again, this pen is just kind of sticking today. There we go. So on the other side, you have your 3 times the quantity of the whole numerator, x plus 3. And then hopefully this will bring back memories, good ones, and we just use our friend, the distributive property, here. So we have 5x minus 5 times 2, 10, equals 3x plus 9. You can start anywhere that you want. Again, this is the coolest thing about this. You can subtract 5x, add 10, subtract 3x, or subtract 9. All you need to do is make sure that you combine your like terms. So right here I see a negative 10. I don't like negatives, so I'm just going to clear that. You easily could have subtracted 3 first. It does not matter. That's the coolest thing about this, like I said. Bring down what's left over. Looks like a stick figure. Okay, so 5x equals 3x plus 19. Well, bring it over. Subtract 3x. Are you guys seeing this pen? Subtract 3x. 5x minus 3x. 2x equals 19. Undo that. And 19 cut in half. 9.5. Okay. I want you to do this one on your own, please. Pause me, come back. Okay, how do we do? I have b equals negative 7 over 5. So again, here you can see all of my work. I just took that 4 times the numerator of 10 minus 8, the 5 times the whole quantity of the other numerator, which is b plus 3, solved it out, and there you have it. I did forget my little distributive property here, but there you go. That's my final answer. All right, when you model a real-world situation with a proportion, you must write the proportions carefully. You can write the proportion so the numerators have the same units and the denominators have the same units. So this is critical. Notice here, it gives you a step-by-step. Correct, you have miles over hours equals miles over hour. Incorrect would be if you flipped those guys. So if you had miles over hours equals hours over miles. No. There we go. All right. So an 8-ounce can of orange juice contains 97 milligrams of vitamin C. About how many milligrams of vitamin C are there in 12-ounce cans of orange juice? Are there in a 12-ounce can? All right. So when I read this, it says about how many milligrams of vitamin C are there in the ounces of cans. So I want vitamin C over the ounces. So my first information is an 8-ounce can is 97 milligrams. The second one is 12-ounce can, and it's asking for how many. So that is going to be my unknown value. So start with what we know. We decided we were going to put vitamin C over ounces. So I have 97 milligrams over my 8-ounce can. I'm going to set that equal to something, but I have to have milligrams on top and my ounces on bottom. Remember, we have to have the same on top and the same on bottom. So I am looking for a 12-ounce can. Well, there's the label, so I know that goes on bottom. Again, it says about how many milligrams, so that is my unknown quantity. All right. Then from here, we should know what to do. Just cross multiply. So 97 times 12, I have no idea what that is. 1,164 equals 8x. Again, you just take that x, multiply it by the 8. So we need to undo the multiplication by using division. I'm just going to flip that to have my x on the left. Then I have 1,164 divided by 8. So 145.5. So going back here, it says about how many milligrams of vitamin C. In this case, you would round up, so it's about 146 milligrams. Don't forget that label if it's a story problem. All right, lesson check. You have 3 problems to complete and get this done, and then we'll go over it tomorrow. Just remember number 3. Look at number 3. When you distribute that, it's not going, or you have to distribute that through. Okay, it's not just going to be 5x minus 1. Okay, guys, I'll see you on the flip side.